Okay, so the null hypothesis basically states that you have two or more things and those things are equal, or if it's a research hypothesis, which a relationship hypothesis, we've already done that. So in this example, sometimes the null hypothesis is represented by H0. This is the mean 1 is equal to mean 2. And all this means is these means are equal. And this is the starting point. And if you remember in class way back, I said, this is the accepted hypothesis until our data show us otherwise. So everything is equal until our data show us otherwise. Okay, so the research hypothesis is that there is a relationship or a difference between two variables, and it's a statement of inequality. In other words, the mean of group 1 is not equal to the mean of group 2, or the pre-test is not equal to the post-test. And there are two types of research hypothesis. When you do this, you can do a directional hypothesis or a non-directional hypothesis. A non-directional hypothesis, this is just saying that there is a difference, but I don't know what that difference is going to be. And this is when we use what's called a two-tailed test. So here's an example. There is a significant difference in body fat as a result of CrossFit training. So I'm not telling you what's going to happen to body fat. I'm just telling you that CrossFit training is going to make a difference in body fat. And it is a two-tailed test, meaning that we are looking for significance on either end of the curve. Okay, so two-tailed just implies that if there's going to be a difference, it doesn't matter whether it can be a decrease in body fat or it could be an increase in body fat. Now, hopefully, we're going to find with CrossFit training there's a decrease in body fat, but we didn't state that. We're just saying that there's going to be a difference, and you use a two-tailed test. In SPSS, it defaults to a two-tailed test. Here's some examples of a null hypothesis, and I'm just going to look at the non-directional for now. So the null hypothesis, there will be no difference in the average score of 9th graders and the average score of 12th graders on the ABC memory test. Non-direction, 12th graders and 9th graders will differ on the ABC memory. And I'll talk a little bit about directional. Okay, so these are some examples. I'm not going to read through all of them. And this is how a research hypothesis is written. It's usually H1. If I had a second one, it would be H2 and H3 and so forth. And all this is saying is that the mean of 1 is not equal to the mean of 2. Okay, so you can do a directional hypothesis, and this gives it direction. So if I do a directional hypothesis, I'm going to say there will be a significant decrease, all right, in body fat as a result of CrossFit training. So this is different than the two-tailed test, because in this hypothesis, I'm giving a direction, okay? So I'm going to say there's a decrease. And the reason I have two of these graphs up here is because your directional hypothesis in this instance is going to be associated with this curve, okay, because our body fat is going to decrease. It's going to be lower than the mean of body fat before we started training. If I had a research hypothesis that was talking about an increase in strength as a result of CrossFit training, then I would be testing on this end of the curve. Okay, so that's a one-tailed test. SPSS is going to default to two-tailed, but you can do a one-tailed test. I always tell students, always write a non-directional hypothesis, because even though you may have a good idea which way it's going to go, it's better to just be safe, and it can go either direction. So differences between null and research hypothesis. No relationship between variables for the null, relationship between variables. Null refers to the population, research refers to the sample. Null is indirectly tested, research is directly tested. So indirectly tested is just saying I'm assuming that this is going to be correct, but then I directly test my research hypothesis. Null is written with Greek symbols, research is written with Roman symbols. Null is an implied hypothesis, and research is explicit. So implied is I'm implying that there's no difference, and explicit is just that I'm going to actually collect data and show that there's a difference. All right, so what makes a good hypothesis? It should be stated in a declarative form. So a declarative form is there will be a significant difference in body fat between pre and post testing. So I am declaring that there is going to be a difference. It may state that there is a relationship. We've already done relationships. It may also reflect a theory or a body of literature on which it is based. All right, so remember, a hypothesis is an educated guess. So you've read something about your topic and you've based a hypothesis based on your reading. Brief and to the point, as we have done, and it is testable. In other words, if I am looking at body fat, I need to be able to measure it. So if you tell me I'm going to measure functional improvement of people with disabilities, I'm going to ask you, how are you going to measure functional improvement? Are you going to measure that in flexibility? Are you going to measure that in strength? Are you going to measure that? How are you measuring that? So you want to define functional um, ability. Okay, that's it. Hope you guys have a great weekend.